Okay, folks, time to help you out again. We're going to be looking at chapter 22, number 10, which is a confidence interval question. We didn't really get to confidence intervals today, so I want to give you a video to help you out with it. This will be a lot like number 9, so if you understand this one, you'll be good on number 9. They did a huge survey, can't remember who, and they contacted more than 25,000 people, adults, looking at whether or not they graduated from high school. In that, they got 12,460 males, and 84.9% of them said that they had graduated high school. And for females, the numbers were here, 12,678 and 88.1% graduated from high school. And what we're going to do is we're going to check assumptions and conditions, just to go over that. We're going to make a 95% confidence interval. They ask us to interpret the confidence interval. And then finally, is this enough evidence that more girls graduate from high school than boys? With a sample size that big, I'm thinking the answer is yes. But we'll find out. Because there's not a huge difference here, but boy, that's a big sample size. So you figure they're pretty close to the right numbers for both of those things. But you never know. So we got to show the work, right? All right. So first, assumptions, conditions. All the stuff same as before. So number 1, you got to ask yourself, is it a random sample? So we're going to assume a random independent sample. Random independent sample of all adults, U.S. adults. You probably wouldn't get marked off for that, but just to be technical. At times I thought, I should just write this stuff on the board ahead of time, but I want to actually go through and write the stuff so that, because it takes time, and so showing you that, you have to write this stuff out, and it does take a little bit of time. I guess I should go through that too and show you the experience. Enjoy. All right, so next up. So it's a random independent sample. Then we got to check that N1, P1, with P hat, because we're using a sample result, has to be greater than 10. And N1, Q1 hat, because it's going to be on our sample, using our sample, has to be greater than 10. So N1, P1 will be 12,460 times the p hat value we got, the sample proportion that we got, and it's that, and that's bigger than 10. Be careful about this. Write down, you don't have to work it out, but make sure you look at it and it looks like it's going to be bigger than 10. Man, that would look really bad if it wasn't bigger than 10 and you just said, oh yeah, it's bigger than 10. You'd look like you weren't paying attention. So just make sure, but here 12,000 times 85%, I think we're good. And so you'd write all this out, and then 12,460 times Q1, which is 0.151. That's greater than 10. And then do the same thing for that was for the males. Now we're doing the women, N2, P2 hat. These subscripts, it's just saying the women, the women. So the number of women we sampled times the sample proportion we got. And all this gets is it gets you your number of successes. Now we don't have to actually work out what that number is. We don't have to do the computation. As long as we're convinced that that number is bigger than 10, then we're okay. And they spent some money to sample 25,000 people, and so they're doing pretty well. N2, P2, Q2 hat. I was just thinking that facial expression I just made probably was awfully strange. Times Q, which is just what's left over, 0.119, and that's greater than 10. Sweet. So we've sampled enough so normal models apply in this situation. So we haven't, we don't have too small a sample. Finally, although they're huge numbers, 12,460 and 12,678 are less than 10% of adult men and women. Cool. And finally, that new one that we had today. So this is the only new assumption condition thing, other than the fact that you have to check both, is that you have to say, we assume that men and women were independently sampled. Meaning that they didn't have a situation where they talked to, like they called on the phone and they talk to the man, or they talk to whoever answered the phone. So man answers the phone, they talk to him, and they say, oh, are there any adult women there? Could we talk to them? And that way we'd get two with the same phone call. That's not independent, because odds are, if the man if there's adult men and women in the household, that if the men have graduated high school, the odds are probably higher that the women have graduated from high school too. Those two things on average probably go together more often than not. So you wouldn't be getting independent values, because if the men were high school, the women were high school. Does that make sense? I hope so. Let me know send me an email if it doesn't make sense. So the men and women have to be totally separately sampled. There's no planned connection between the men and the women that you got in your samples. Okay? If you happen to get a man and woman who are like a married couple or something like that, that's okay. There's nothing wrong with that, as long as it just sort of happened, as long as it's not something that was built in. All right, so that's the assumptions conditions. Now the 95% confidence interval. So let's just do the basic idea. The 95% for any confidence interval, it's our value plus or minus the number of standard deviations times the standard deviation of our statistic. That's the basic thing that we're always going to be setting up. All our confidence intervals are going to look something like this. Now in this case, what are we trying to find a confidence interval for? We're trying to find the confidence interval, if you read it, for the difference between men and women. So we want to know, well, okay, we got a difference of, I don't know, I'll figure it out, how big a difference there is here. But we know that, like, we could have, it could be a little bit more, it could be a little less. I mean, we don't know what the actual value is. We just know that's what we happen to get with our samples. So we're going to make a confidence interval, a range, that we think the real number is somewhere in that range. So ours, remember, is like one example, one possibility, and we're making a range around it to say we think the real difference is somewhere in this range. So you start with the value. What's the value we're looking at? We're looking at what P2 hat minus P1 hat. I didn't define them here, but you could put it up here. Let's see, so P1 is proportion of men, and P2 is proportion of women who graduated high school. I hope that's on the screen. If it's not,